Hello, welcome to my YouTube channel. Today we are going to learn the second topic in the deep learning first unit, that is the linear models. Linear models include SVM, perceptron and logistic regression. So the first topic, that is the SVM. SVM stands for support vector machine. SVM is a linear model for classification and regression problems. It can also solve linear, nonlinear problems and work well for many practical problems. It tries to classify the data by finding a hyperplane that maximizes the margin between the classes in the training data. SVM is an example of large margin classifier. The idea of SVM is simple. The algorithm creates a line or hyperplane which separates the data into classes. Like large amount of mixed data is there. By using the SVM, we are classifying the data into class 1, class 2, class 3, class 4, and that separating line is called as a hyperplane. These are the necessary diagrams for the SVM topic. According to the SVM algorithm, we find the points closest to the line from both the classes. These points are called the support vectors. We compute the distance between the line and the support vector. Thus, distance is called as a margin. Our goal is to max the margin. The hyperplane for which the margin is maximum is optimal hyperplane. SVM tries to make the way that the separating between the two classes is wide as possible. So we need to find the support vector, margin, optimal hyperplane in the SVM. And these are the important definitions regarding the SVM. So now we are going to see about the SVM kernels. So SVM can work well in nonlinear data and the linear data using the kernel trick. So the function of the kernel trick is to map the low dimensional input data space and transform it into the higher dimensional space. So what is the function of the SVM kernel is to converting or mapping the low dimensional input data space into the high dimensional space. So kernel convert non-separable problems into separable problems by adding more dimensions to it. So what it will do? It will convert the non-separable problems into separable problems by adding the more dimensions to it. So it makes the SVM more powerful and flexible, accurate. These SVM kernels make the SVM more flexible, accurate. This is the not linearly separable example, and it is a mixed version of 2D and 3D. This is the 2D and this is the 3D. Mainly, there are 4 parameters in the SVM, that is a C, gamma, kernel and poly. C means regularization parameter, means trade-off between the smooth decision boundary level and the misclassification. Next one is a gamma, kernel coefficient. It is for nonlinear kernel, higher the gain value for it. And the third one is the kernel, we know about it. And fourth one is a poly, means degree up to what power use when the data is. Now we will see the types of SVM. There are mainly 4 types: linear kernel, polynomial kernel, Gaussian kernel, exponential or Laplace kernel. So linear kernel means it is used when the data type is linearly separable. Formula is k of x comma y is equal to x into y. Second one is a polynomial kernel. It is used when the data is not linearly separable, means k of x comma y is equal to k into x plus c into d. Third one is a Gaussian kernel. It is used to perform the trading transformation when there is no prior knowledge about the data. When there is no prior knowledge, then the Gaussian kernel is used. That is k of x comma y is equal to c of minus gamma or x minus y or power of 2. Fourth one is a exponential or Laplace kernel. It can be used to measure the similarity or distance between the two input feature vectors. Example is the SVM. SVM is divided into two types. One is a linear SVM and another one is a non-linear SVM. So we will go through the linear SVM first. Two input variables, that is a class A, that is a positive label, and class B negative labeled. So these are the input values 3 comma 1, 3 comma minus 1, 3 comma 6 comma 1, 6 comma minus 1. This is a class A totally positive. And class B 1 comma 0, 0 comma 1, 0 comma minus 1, minus 1 comma 0. This is a negatively labeled, that is a class B. Now by pointing all these in the x-axis and y-axis, we will get the points like this. Like 3 comma 1 means x-axis 3 and y-axis 1. This is a point. 3 comma minus 1 means x-axis 3, y-axis minus 1, and where we will get the point 3 and minus 1 here. Like that, by plotting all this, we got the diagram like this, and the middle one between the these line is a hyperplane. This place is known as the hyperplane. So first of all, what is a process is that we have to identify the support vectors first. Support vectors mean the points which are nearer to the hyperplane. So this is the 1 point. 1 comma 0 is a 1 point, first one. This one 1 comma 0, this one is a first pointer, and another one is a 3 comma 1. 3 comma 1 means here this point. These are the nearer points to the hyperplane. 1 comma 0, 3 comma 1 and 3 comma minus 1. 3 comma minus 1, this point. So these are the support vectors we are getting nearer to the hyperplane. Second step is the adding bias. So S1 is equal to 1 comma 0, S2 is equal to 1 0 1, S2 is equal to 3 comma 1, S2 bar is equal to 3 1 1, S3 is equal to 3 comma minus 1, S3 bar is equal to 3 minus 1 1. Now we have to find the support vectors through alpha 1 S1 bar plus alpha 2 S2 bar S1 bar, alpha 3 S3 bar S1 bar is equal to 1 minus 1 due to it is negative labeled. In the similar way, we have to write the remaining two functions. Remember this, here in the first case S1 bar is common in all the cases because of we are finding the first equation, and we are finding the value to the second equation, means S2 bar common here, and next one is the S3 bar is common. Alpha 1, alpha 2, alpha 3, alpha 1, alpha 2, alpha 3, alpha 1, alpha 2, alpha 3. In each and every case, we are finding the alpha 1, alpha 2, alpha 3, and the term to which equation we are finding the values, that also common, and the changing one is remaining the S1 bar, S2 bar and S3 bar. S1 bar, S2 bar and S3 bar. These are the changing values because we are finding the alpha, beta, gamma values. Now by doing the dot product of above products, we will get alpha 1 value S1 bar plus alpha 2 value S2 bar S1 bar plus alpha 3 value S3 bar S1 bar is equal to minus 1. By doing the dot product, like 1 is a 1 and 1 0 0 0 means 0, 1 1 means 1, 1 plus 0 plus 0, like that we will get the equation as 2 alpha 1 plus 4 alpha 2 plus 4 alpha 3 is equal to minus 1. By solving the above three equations, we will get the value as alpha 1 is equal to minus 3.5, alpha 2 is equal to 0.75, alpha 3 is equal to 0.75. To find the hyperplane, the formula is summation I to n alpha I si bar. By expanding this formula, we will get alpha 1 S1 bar, alpha 2 S2 bar plus alpha 3 S3 bar. By substituting all the values, we will get the values as 1 0 minus 2. So the hyperplane equation is y is equal to wx plus b. So w equal to 1 comma 0 and b is minus 2. So the final answer is, the answer will be the parallel to y-axis. In the SVM, there are two types again, linear and the non-linear. And the example for the non-linear is inputs we have taken as 2, 2, 2 minus 2, minus 2, minus 2, minus 2, 2. These are the points. And another point is 1, 1, 1 minus 1, minus 1, minus 1, minus 1. So by plotting all the points here, we got this point, here and here, this sign, this, and here also. So now our goal is to discover a separately hyperplane that accurately discriminates the two classes. So of course it is obvious that no such hyperplane exists in the input space because of it is a non-linear SVM. Therefore we must use a non-linear SVM, that is we need to convert the data from one feature space to another feature space. So for that the formula is phi1 of x1 comma x2 is equal to 4 minus x2 plus mod of x1 minus x2, 4 minus x2 plus mod of x1 minus x2, x1 comma x2 if this condition is applied when x under root of x1 square plus x2 square greater than 2, and x1 comma x2 otherwise if this condition is not satisfied. For example, here x1 2 comma 2, x1 value is a 2, x2 value is the 2, plus 2 minus 2 minus 2 minus 2 minus 2 minus 2. So by substituting the above equation, we get the point size 6 comma 6, 6 comma 10. Similarly, and for another point 1 comma 1 minus 1 comma minus 1 minus 1 comma minus 1 minus 1 comma 1. So by substituting the formula, we get the point size 1 minus 1 minus 1 minus 1 minus 1 1. So by plotting the all the points, we get the hyperplane like this. So now we have to find the same linear example way. First one we have to find the support vector. S1 is equal to 1 comma 1, S2 is equal to 2 comma 2. And we have to, second step is to add bias. S1 bar is equal to 1 1 1, S2 bar is equal to 2 2 1. Similar way, alpha 1 alpha 2, alpha 1 alpha 2, S1 bar is common, S2 bar is common. We have to find the two values, S1 bar comma S2 bar. So by substituting the values, we will get an equation. By solving that equation, we will get the value as alpha 1 is equal to minus 7, alpha 2 is equal to minus 4. So we have to find the lastly the values of the hyperplane. So for that we have to find out the hyperplane. Hyperplane W bar is equal to summation of I to n alpha I si bar. So by solving that equation, alpha 1 plus S1 bar, alpha 2 S2 bar, we will get the values as 1 1 minus 3. So the hyperplane equation is y is equal to wx plus b. So 1 1 minus 3 means the angle should be, hyperplane angle should be 45 degrees, like this. The angle should be 45 degrees. This is all about the linear and non-linear SVM. In the next class, we will see the types of regression and the related problems to it. If you like the content, do subscribe to the channel and hit the bell icon.